Hey guys, this is Archimedes Tutor here and welcome to my very first lesson. I'm going to be starting off with grade 11 math and our first unit is trigonometry. I hope you guys enjoyed it last year. So the first lesson is recalling basics from grade 10. Let's begin with the primary ratios. So as you know, primary ratios are always used for right triangles. So I have my reference angle here. And obviously this is the hypotenuse since it's the longest side and is opposite the right angle. Opposite this reference angle will be this side. So let's call this OPP, or hypotenuse it's called. And the adjacent side will be called adjacent, or ADJ. So there are three ratios taught in grade 10. One of them is the sine ratio, which states that the sine of the reference angle is equal to the opposite, or hypotenuse, over hypotenuse. Or to break it down, the reference angle itself is equal to the inverse function of sine times opposite divided by the hypotenuse. This is the cosine ratio, that's the second ratio. It states that cos of the reference angle is equal to adjacent over hypotenuse, or the reference angle is equal to the inverse of cosine times adjacent divided by hypotenuse. And the third is the tangent ratio, which states that the tan of the reference angle is equal to the opposite, or hypotenuse, divided by the adjacent. So the reference angle is equal to the inverse of tan times opposite divided by the adjacent. I have a problem set up for practice. So I have triangle QRS and I need to find the reference angle S. I have the given sides. QR is 7 centimeters and RS is 9 centimeters. So what ratio shall I use? So the reference angle, and there's a side opposite to the reference angle and one side adjacent to the reference angle. So I need to use a ratio that includes the opposite and adjacent. Since tan is a ratio where there's opposite and adjacent but not hypotenuse, I shall use tan. Reference angle equals tan inverse of opposite, which is 7 centimeters because it's opposite the reference angle, so 7 centimeters, divided by adjacent. RS is adjacent to the reference angle. Then let me just plug it into my calculator here. So I'm going to press shift and then the inverse tangent function, tan of -1, tan to the power of -1, in brackets 7 divided by 9, and that gives us approximately 38 degrees. To the nearest degree it will be 38 degrees. So the reference angle is equal to 38 degrees. How about we find the side length now? So I have triangle DEF. I have the angle 54 degrees at F, and the hypotenuse, which is opposite the right angle, is 10 meters. I need to find the value of x. So let's recall our learning. The hypotenuse, I have the hypotenuse and the reference angle, and I have x, which is adjacent to the hypotenuse. So which ratio shall I use? The cosine ratio, because it's adjacent over hypotenuse. I have the adjacent and hypotenuse. So let's find the adjacent. So I have cos of angle 54 equals x over the hypotenuse, which is 10 meters. Now, to isolate for x, I'm going to multiply both sides by 10 meters. And that will give me an answer of x equals, let me substitute it in my calculator. So this time I have cosine of 54. That equals to a value of 0.58778, etc. And I'm multiplying it by 10 meters to isolate for x, times 10, and that will give me 5.87785, or approximately 5.9. So therefore x equals approximately 5.9 meters. Now let's move on to the sine law. The sine law is used for triangles other than right triangles, such as isosceles triangles, scalene triangles, equilateral triangles, etc. So basically it involves the side lengths and their corresponding angles, or opposite angles. So I have angle B, and its opposite will be AC, labeled lowercase b. And I have angle A, its opposite will be side length BC, labeled lowercase a. So the ratio of a side length and its opposite angles is equal to other pairs of sides and angles within the triangle. So for example, I have sine of A, angle A, over side length A, which is equal to sine of angle B, which is over side length B, and etc. So whenever a sine law problem is given, you should look for the information such as a pair of corresponding side and angle, and another pair such as an angle and its opposite side lengths. In a triangular garden labeled with points A, B, C, let me just do that right now. A, B, C. Angle A is 46 degrees. AC is 8 meters. And the angle opposite AC is 32 degrees. Find BC. Find the length of BC. Given a side length, 8 meters, and I also have its opposite angle, which is 32 degrees at angle B. And I'm also given another angle, and I need to find its opposite, which is BC. So I can write this and substitute this into my equation. So let sine of B be represented by sine of 32 degrees, and its opposite is 8 meters, which is lowercase b. And let sine of A be represented by sine of 46, and its lowercase or side length is BC. I'm going to solve this using the cross multiplication rule. So I'm going to multiply sine of 32 with BC and sine of 46 with 8 meters. So let me just write that down. Sine of 32 degrees is equal to sine of 46 times 8 meters. So now I'm going to isolate BC, and the only way I can do that will be to divide sine of 32 from both sides. Well, it's not the only way, but it's the most easiest way. And these two cancel out, and we're left with BC equals approximate sine, obviously, of course. And let me just plug it into my calculator. So I'm going to press sine of 46 times 8 meters. 8 meters divided by, in brackets, sine of 32. 10.8596. I'm going to round it to the nearest 10 and say 10.9 meters. So BC equals 10.9 meters approximately. And that's it. That's all you have to do. But there's always the question of the ambiguous case of the sine law, which is another concept taught in grade 10. It means that there may be two answers to a solution. There may be two answers to a question. And this is because those two angles may be supplementary. So when their sine function is taken, the result is the same. For example, sine of 85 is 0.99619, and sine of 95 is also 0.99619. And this is because those two angles add up to 180 degrees. So one way to determine if there are two solutions, one solution, or zero solutions, there's a trick you need to remember. So let me just draw a box here. Not the best box. So if A is greater than B sine A, that means there are two solutions. If A is equal to B sine A, there are one solution. If A is less than B times sine A, there are zero solutions. No solutions. And that's the trick I learned. So if side length A is greater than B times the sine of angle A, there are two solutions. Our third concept is the cosine law, another method of determining a side length or an angle. So the cosine law, developed from the Pythagorean theorem, can be used when three sides are given and an angle needs to be found, such as angle A, or can be used when two sides are given and an angle is contained between them. And the formula of cosine law can be a pain to remember. Let me write it down for you. A squared, A refers to a side length, such as BC is its opposite, equals B squared plus C squared minus 2BC and cos times cos of A. Let's do a practice question. Suppose this is 2 meters, that's 3 meters, and the angle contained between them is 40 degrees. I'm going to substitute it into my formula. This is A, and that's cos A. So A squared equals, B can be 2 meters, 2 meters squared, plus 3 meters squared, minus 2 meters, times 3 meters, times the cos of 40 degrees. Using BEDMAS, I'm going to solve this portion right here first. So 2 times 2, 4, times 3, 12. Okay, and cos of 40 times 12 gives us approximately 9.19 meters. So I'm going to write that. And 2 squared plus 3 squared will be 13 meters squared. So A squared is equal to 13 meters squared minus 9.19 meters squared. Now to find the value of A only, I'm going to square root both sides. Plug it into my calculator. So the square root of 13 minus 9.19 is approximately 1.95. So A is equal to approximately 1.95. And that's it. That's all for today, folks. Thanks for watching, guys. If you found this video helpful, please be sure to subscribe. For more info on myself and the lessons I will be uploading in the next few weeks, please visit my website, www.archimedestutor.com.